Let me screen share real quick. Hi, my name is Tejus, and my project was attempting to make a material detection model using ML and AI. So when we look at this glass bottle, like we're humans, we can tell what it is, right? We look at it, we've learned from like years of experience that it's a glass bottle. But like when you give it to a machine, the machine doesn't really know what it is. It just sees a bunch of pixels. And if you wanted to recognize that it's made out of glass, we need to train it, and we need to tell it what makes it a glass bottle, and that's kind of the crux of the problem. So I had two major challenges because material recognition is not something that like it's very like widespread, like not many people have done it. So I couldn't find a data set, and the only data set I could find was it was like garbage classification. So it had like different materials such as plastic, glass, it had cardboard, metal, paper. So it was like a good build, it was a good starting point, but it barely had like 30, 40 images in each class, in each label. So I ended up adding like 1,000 images using Jason's like Google search to, Jason had like this tool which allows you to download Google image search images. So that allowed me to add like 1,000 images, and that I created my data set like that. The second problem is actually having a model that you train your images on. And here's where I spent like an entire week trying like different models. I tried to build my own, and that didn't work. I tried like 2 or 3 different like pre-trained models, and I ended up realizing that computer vision doesn't really work very well when you're trying to classify like different images, or when you're trying to classify different materials. So I ended up having like a pipeline. So basically, I ended up with a traditionally image computer vision type of model, but instead of using it to classify my images, I use it to extract different features from my image. So for example, for that glass bottle, it would see that, oh, look, it's like transparent. So it has opacity, and it determines that it's a bottle because look at its shape. So it trains on the shape of it, and it trains on the color and everything like that. So it does that for different materials such as cardboard and plastic. And it feeds those different features into my actual model, which is called a random forest classifier. So what that does is it looks at like the different features and it compares it to what it's actually learned on. And so it will decide whether it's made out of cardboard or plastic based on what features you gave it. And oh, here it is. So my model is actually 71% accurate. It actually jumped up from the last time I tested it. So before it was like 65%. So it's like decent, but it seems kind of low. But when you think about it, it's classifying 5 different labels of materials. So like a 70 or 65, like around that range is actually really good for a model like this. And we can actually test this model out right now. So these are images that the model has never seen before. This is like an image of a cardboard box, and the model actually predicted a cardboard box. And this is like a packaging of like a pan, I guess. And so you can tell that like these don't look like the same thing, but we all know that this is cardboard, and the computer can also tell that it's cardboard because it looks at the material. So it knows when to look at the color and the shape, and it also knows when to look at like the texture of the object. And we can test it a little bit more. We can like, it knows it's a glass jar. You can see that it's transparent. It'll look at the shape of it. And this is like a crushed can. So it'll look at like the reflectivity of the object, and you'll see like how the light bounces off of the object and its shape as well. So it classifies this as metal. And so my final to top it all off, I wanted to create like a web app. So basically this is the same thing that it runs my model, but like it's on the internet, so anyone can like input their own image and then run the model for themselves instead of like only me being able to run it off of my computer. But like I haven't really gotten it to work fully, so it's still a work in progress. So at the end, like this was my second time working on an AI project, so I really learned a lot. This time I had like a lot more problems because I was on my own. So I had to like, every time I solved one problem, there was like 5 more that I had to solve. And I came to Bluestamp to find out like whether I liked engineering or not. And I found that as long as I don't really like burn myself out on projects, like working like 3 or 4 hours on something that doesn't really end up working, if I give myself a break and then keep working on it, I actually like enjoy it a lot. And it's actually very rewarding. So yeah, that wraps up my presentation. Thanks.